Good afternoon, guys. This is Samim Akhtar. Let's do some little teamwork over here. First of all, welcome to Philadelphia, our hometown over here. And I had a quick question for all of you. It's a trivia question. How many of you could have our juicy Philly cheesesteak this lunch? Great, great, great. I'm sure next couple of days will be a good time for you to at least not be the deprived one and do bag it home as well. The next question for the carriers is, how many of you have not toyed with 100 gig gears just yet? Good. Looks like everybody has tried 100 gig in some form or somewhere or the other. So with that, I'm going to start with the topic of discussion about the fact that a smooth landing of technology requires some level of expectation for our technology partners. We do expect them to be working on a certain set of rules, and that's not only applicable to 100 gig, it's applicable to any technology life cycle. So the certain items probably most of us always keep thinking about that, the requirement which our vendors, our technology partners are they getting in all in one place or a comprehensive set of tool sets to understand as to what we need and when we need that versus in piecemeals. And I think we as a carrier definitely are in driver's seat in terms of giving the end-to-end requirement or use cases. That not only is specific to the fact that we want 100 gig by this date, we do need to articulate the use cases which not only captures the details around the network architecture we have and what constraint we're trying to solve by which year level of details. I mean, you may have details around the 100 gig by a carrier who is constrained by fiber and needs to have spectral efficiency. That's one use case. But other use case is I have no space and power. I need to have higher density, and I need to have 100 gig on my routers or switches today. Or likewise, I just do not like the connectivity story so far, and it's very expensive, and you guys need to fix that problem. So of course, different standard bodies, we do participate on that, and we tend to drive some of the technologies. But we as a carrier definitely tend to have a good level, a good sense, of control over how things need to project manage itself, in an autopilot mode, so that when it lands, we took care of all the pieces, and we can say for every use case is applicable. And that's what I call, smooth landing of technology. So let's talk about 100 gig. It's a 4 characters, 100 and G, and and we definitely don't want 4 letters in there, a 4-letter word out of that. But the question here is that when you talk about optimizing the 100 gig technology, you're talking about optimizing in 3 different angles. There was a need for a spectral efficiency, and there was a good place for innovation to come in. Some proprietary dual carrier 100 gig came in, then the first generation, and now comes the second generation part of it. Some of the limitation was around ASICs, the DSP part of it. The CMOS solved some of the problems. The soft FEC is coming in. There's all good stuff happening on a spectral efficiency part of it, to whatever extent it could. There are limitations in terms of Shannon sampling theorem. We understand that, but under the constraints we have, I think it's kind of going in the right direction based on the fact that OIF, together with ITU, took over the challenge to do this time the photonic and the line size a little bit differently. When you talk about the vertical axis over here, the MAC efficiency, I think that's pretty relevant. It's getting very relevant for the carrier like us who do triple play. Triple play means we do triple and quad play on the same infrastructures. We have one converged network, and that's true pretty much for all the carriers day by day, where you tend to have one operation model against an infrastructure what you got. So again, the smooth landing expectation for that was, if the Moore's law is really applicable and is doing pretty well on a MAC efficiency, you would rather have the ASICs coming in the right form factor, and we can use that as a baseline, as a 100 gig ASIC or 100 gig MAC. So of course that had some hiccups. There's a gap between what gets released in the press and what comes in as a deployable technology. That gap needs to shorten, and I think we as a carrier play a big role in terms of level setting as to what we need and what does that press release mean to us. There are complexities in terms of upgrades. Once we upgrade our switches and routers, we always have a big planning that goes on to play as to You have the RGUs, the revenue generating unit, hooked onto the infrastructure, and any outage, even for a half an hour, is a big deal for us. It's a quality of experience impact, what we call a scorecard. And if that outage happens on a large scale affecting millions of customers, definitely has its own impact. So the fundamental architecture in terms of handling the migration or upgrade path is another important constraint. Connectivity. Connectivity has been a pretty trivial piece of work historically being done in a 1 gig, 10 gig space. But the 100 gig brought a new paradigm in terms of how we can solve that problem and how differently we can solve the problem. Of course, IEEE did a great job to begin with, to start with the LR4 CFPs, but things started to dwindle down when the cost parameter came into play, which fundamentally broke the whole cost curve, what we see in 10 gig space, where things have stabilized to an extent where we kind of measure everything in SAP plus normalized cost, but the LR4 wasn't the case. So of course we all together, our friend fraternity together got up and say, we don't like that, we want to fix that problem. Went to LR10, tried that, still trying it. But at the same time, there was one thing inherently there, which most of the carriers probably would appreciate the fact that the whole multi-mode active cable space, which could have fixed 80% of our use cases as a low-cost interconnectivity between the router and transport, which we didn't pay attention to on the right time, where you had the standard being developed a couple of years back, but however, we could not really execute upon that in a timely fashion. And now we are probably 6 to 9 months late in terms of having a right connectivity, a low-cost connectivity for ourselves. So, of course, when you see 3 dimensions over there for 100 gig, you need to land all these 3 areas of flexibility at the same time. So that's a function of time, right? And that's one of the things which probably we carriers have a lot of heavy lifting to be done. And probably, what I'll do is that kind of talk about a perspective about how we can fix things in a terabit space. If you talk about terabit, morning talk and brocade, pretty good, and terabit looks pretty awesome. But at the same time, we kind of know the fact that 400 gig is pretty linear thinking. We have bill of material of what we can do, and 400 gig is going to be a reality even if you don't want to take it, right? But again, when you talk about a 1 terabit technology, I think we're talking about a tool set which is fundamentally different from what we have in the current space. Better I/O speed. We keep talking about, we have respite till 2015, 17, but I tend to agree about respite. We have the respite, knowing the fact we can linearly think and bring a 400 gig out. When we talk about a terabit, I think we need to have some out-of-the-box thinking. We need to bring some thought process which is not limited to just electrical domain, I/O speed in the circuit board. We need to have full bill of material or total TCO analysis in terms of how the end-to-end power space and cooling needs to be optimized. At the same time, the whole MLD approach, what we have, and the whole 25 or 28 gig VSR project which is coming along, I think it's a good path towards 400 gig, but I think thinking beyond a terabit, when I call that a terabit, I do not call a terabit by any means at the end of the road. It's going to be a terabit and beyond story. And that story, of course, needs some fundamental change in thinking in terms of how the MLD is being done, the multi-lane distribution. Fiber side, I think we know, the Shannon's limit is always there. Super channel is going to fix some of the problems. It's a temporary relief. But at the same time, I think we have bigger challenge in terms of the whole network architecture. We had morning session with Dave, and Dave talked about the fact that, application-aware network complementing the applications. I think there's a lot of work to be done. I think easier said than done. We carrier understand the pain about the fact that if you empower the content providers or content developers to be creative in terms of steering traffic on the network, we should be doing the same thing, knowing the fact that an application is running, how we tweak a network, but they should not collide. They should complement. And that complement means a good bit of collaboration with top carriers and top content providers. And I think we all need to fix that problem early in the stage so that we can dampen the bandwidth exafloat we have on a core, so that we can dampen the WAN side spectral efficiency concern we have. So we're trying to elongate the life of our fiber. At the same time, having said that, it doesn't undermine the fact that we don't need a terabit. We need a terabit for LAN applications. That is connectivity of machines, connectivity of switches and routers. So that's my 2 cents about the efficiency of terabit. And when you talk about this whole standards effort which has gone on in the past, I think we left the work of the land side to IEEE, ITU, and OIF, fix some of the WAN side. I think this is pretty disjoint. I need to fix that. Piecemeal ownership is not productive. And with that, I'll probably open up with some questions, and I have plenty of details around each of these thought process of most of the talks I've given this year, so probably you can take a look at that as well.
Very nice. Thank you very much. Any questions? We are right up on the hour. We have done quite well here. All right. Thank you very much.
Thanks.